Anupam sir, you are not audible.
Am I audible now?
Yes, now it is okay. Fine.
मेरा 1 घंटे में हो जाएगी।
हेलो हो गया अनिल? हाँ ओके आपका हो जाएगा।
मैं रिंग कर दूंगा। हेलो गोपाल।
Hello sir.
Hello Ashish, have you joined?
Yes, sir. How are
Yes,
you?
sir.
Hello, Anupam, sir.
Good evening, sir.
So I think Gopal, I think I cannot share my screen for some reason. Do you think it's because you're sharing something, or I just want to check
Yes.
if I can share my slides?
Yes, you can share now. Anupriti, madam, please give the permission to the assistant so that he can share.
Sir, please check once. Now you can share your screen.
I just want to check if I can share my slides.
Share now.
Sir, I give you authority. Now you can share your screen.
Okay.
Please check
Okay.
once.
Can everyone see my screen?
Yes, it is visible, sir.
I could unshare it just to let you guys the intro.
Yeah, it is not, now it is shared.
Yeah, I unshared it just in case if you want to share something. I don't know.
I think Anupam sir has some internet connectivity issues. So we call him.
Worst case analysis तो बोल. Hello, am I audible? नहीं उसमें ऑडिबल है वो उसमें वेबएक्स में ओके
Yes, sir. You're audible, sir.
Okay, so I think this is there is some. I am actually not in Prayagraj. I am elsewhere.
Sir, your audio is not clear.
So there is some internet problem here, but I hope uh, I am Dr. Kokila.
Yes, sir.
I
I think we can
uh,
start the session.
Yes, ma'am, we can, shall we start, ma'am?
Yes, sir.
yeah, actually, I am out of
Okay, sir, no problem, sir. We
Yeah.
will, we can take care.
Raj. I am I'm at a place where internet connectivity is an issue. So I request Dr. Kokila to, I request first Gopal to start and then Dr. Kokila to take over.
Okay, sir. Okay. So, Kokila madam, shall I start?
Yes, sir, we can start.
Okay. So, good morning, Ashish sir. Good evening to all who have joined from India. Myself, Gopal Chandra Jana, being a moderator of this session, on behalf of Alumni Affairs Triple IT Allahabad, I really feel privileged to welcoming you all in this Alumni webinar series 8. Unfortunately, we don't have our chief guest with us right now. He's busy in some meetings, our Honorable Director sir. With us, Anupam sir also is there in Alumni Affairs, but he has some internet connectivity issues. With us, our panel member, Dr. Triloki Pant sir, Dr. Kokila madam, Dr. Navjit Singh sir, Dr. Radhika madam, and Dr. Anjali madam. And welcome panelists. Also, I'm welcoming all the faculty members, students, alumni who have joined this webinar. With us, our distinguished alumni and speaker of this webinar, Dr. Ashish Prabhu from Spotify, New York, USA. Welcome, Ashish sir. Now I request on behalf of Dean Alumni Affairs, Dr. Anupam Agrawal, let Kakuli Madam to give some welcome address and give some speaker introduction, please. Please, Kakuli Madam, you can start. And over to you, Kokila Madam.
Yes, Ankruti, I think you can give a welcome address for sir, and we can start the session. So, in behalf of Alumni Affairs, I welcome you, sir, Dr. Ashish Papu, sir, for this webinar. And the topic seems to be very interesting, and we are very eager to hear from you. Yes, sir. I think you can start the session. So, at the in between, we can have some queries, or at the all the things we can discuss.
Sounds good. I believe everyone can see my screen right now.
Yes.
I think good evening, everyone, joining from Triple IT and anywhere else. Good morning, or good afternoon, or good night, or whatever. So this is actually quite refreshing, actually, to come back and speak at my alma mater. I would say this is labeled as a journey through time and space, and I was because I will briefly jog you through what I've been or how it started. And I took the train to Allahabad. We were three friends from Vizag in Andhra Pradesh. It was a 36-hour train, right? Basically, it was two different trains that you had to take. to get to Allahabad, and that was my first time to Allahabad, and it was obviously the 12 kilometers bus rides to NSC campus back when the Jelwa campus was still under construction. This was in 2003, or the campus was there but not ready for the freshers. So 6 months of intro days, as you know what intro days are, and then of course 24 hours of learning and fun. So we have been actively involved in a lot of learning activities, of course, and also the fun activities due to the the internet. Then of course the bus to Cannington. So for those who did not know, this Cannington was actually the original name for civil lines. So you can spot me there in a red sweatshirt. So obviously we were standing right near Tandoor. That used to be most of our birthday parties used to be at Tandoor, and of course ILB, which used to frequent, and of course the Palace Cinema, Cathedral during the Christmas days, and of course the Indian Coffee House, which was really like memorable times we had. And of course, then we fast forward to 2007, all of us, like some of us actually, got to EPFL. So 5 of my batchmates, including me, we got an internship at EPFL. So it was a great opportunity to get paid and learn, hike. There are a lot of mountains in Switzerland. So obviously had fun. So you got to see both the paved roads and also the cobblestones, and of course hike through the mountains and bike through these valleys. Obviously we had IIIT friends, but also made some friends during the internship. So yeah, I mean, we are still in touch. 4 of my friends, including me in this photograph, they all have done their PhDs in different disciplines from different universities. So I think we are still continuing the academic journey of sorts. Teleported to Pittsburgh, 9 IIITians in this case, as you can see, all from different batches, 2001 to 2004. Like some of the names are listed there, or other names are listed there. What is so interesting about Pittsburgh is that it's, even though it's 9,000 miles away from Allahabad, you still have those 3 rivers, just the names are different: Ohio, Monongahela, Allegheny rivers. So the Sangam follows us wherever we go. So, and of course the Tandoor too, the restaurant that you are seeing there, where we seated, was also called Tandoor. So strangely, so we got teleported to Pittsburgh as a trip. And in the summer of 2014, I got I defended my PhD. So that was after several dreadful winters. So Pittsburgh is like, if you've seen winters, then like maybe Delhi winters, then multiply them by 100, or maybe even 200, and that is the kind of winters you would see in Pittsburgh. A lot of snow, slippery slopes. So, and there are also hills in Pittsburgh, so you would be walking, taking long walks on those slippery slopes, especially when you miss your bus, the last bus. You would be working in your lab at 1 a.m. or so for working on a paper, and then you come want to go home, like maybe 1 mile away, 2 miles away. You would be just walking on those slippery slopes, and a couple of times I even slipped off, and both proverbially and literally. So obviously, when I said proverbially, obviously the papers that get rejected, and obviously when the papers get accepted, you feel happy about them. On the way, I also got to organize some workshops, and I had the opportunity to represent Carnegie Mellon at various conferences, and had several burn of coffees and free pizzas. And so the photographs that you see there are obviously when I got hooded. So it's a very proud moment for my parents that I got a PhD from a reputed university in artificial intelligence. So of course you get, after those burnt coffees and free pizzas, you are looking forward to like awesome pastries. So if you ever get a chance to visit Pittsburgh, there is this nice French patisserie called Gaby et Joel. So it has best patisseries. Cool. So that's after my PhD. Then there is this famous Frank Sinatra song, New York, New York, where he actually says, "If I can make it there, I can make it anywhere." It really speaks of New York City. And so I got my research scientist position at Yahoo Research in New York, and the office was right at Times Square. So that was the photograph of Yahoo office at Times Square, and it was like really like a great feeling to be in the center of everywhere, the universal kind of thing that people imagine to be in. At Yahoo Research, I was really fortunate to work with excellent collaborators and colleagues. And in year 2018, I received a Master Inventor Award at Yahoo, which was primarily for innovative and novel work and patentable work that we do. So I was fortunate to file nearly 15 patents with my colleagues at Yahoo. On the way, we also open source several libraries and data sets that will be very useful for academic communities and in natural language processing and machine learning. I have had several academic collaborations, including CMU. I was fortunate to visit CMU even after graduation in the capacity of a project investigator, working with my advisor and other professors at Carnegie Mellon. Also collaborated with Cornell Tech, which is based out of New York City, and also the University of Michigan in Ann Arbor. So now I'm at Spotify working on large-scale multilingual audio search problems. We recently released one of the largest audio data sets and the largest podcast data set, including the transcript. So this is again very useful for academic communities where you have very little labeled audio data, and this is one of the largest labeled audio data sets available in the literature. This was, and we still continue to contribute to this data set in the form of Trek. Trek is this annual conference run by NIST, and it is very prestigious and has been around for a while. And they organize various evaluations on the various research systems. So I definitely recommend you to check it out in the upcoming, like in the upcoming years or sessions. As a fun fact, I also realized that I can run. So I ran a New York City marathon. The 42 kilometers was as dreadful as those Pittsburgh winters, but well, I want to be part of it as the song goes. So if you're in New York, definitely, yeah, it's a great place to be in, and I think yeah, I'll tell you more about New York, like when you can ping me offline. So today, the talk is primarily about the query understanding and intent prediction for music and podcasts. This is a very recent work with several of my collaborators from Spotify, and we recently presented this work at KDD, and some part of this work is also presented at the previous year CIKM. So at Spotify, I've been, like I said, collaborated with on several papers with people from different areas, so knowledge graphs, search and retrieval, and natural language processing, which is my primary area of interest. So yeah, this was pretty productive 2 years so far at Spotify. So the work that I'm presenting today, or in this section, is neural instant search for music and podcasts. This is joint work with our intern Helia Hashimi from University of Massachusetts, Praveen, me, Munya, and Ben. And I presented this work at KDD 2021, which was in August this year. So if you know, podcast has been like pretty actively consumed or created medium of interaction. And as you would notice from the statistics, 37% of people in the US have been listening to the podcast in 1 month period. And there was a Twitter fun fact where nearly 1 million episodes, podcast episodes, get released every year. So that's like 1 million of, if you imagine 60 minutes of a podcast, and you have those 60 million minutes of human speech. And that's a lot of audio data that we can imagine. And also, it's not just any audio data. It is not like random YouTube clips or Instagram reels. It is real meaningful content that people are talking, either from their basements, or they're talking from their, I don't know, like a studio. So yeah, so for those, just a fun fact, for those you may have visited the Nehru Science Center campus, you would see the All India Radio studio right next to the classrooms. And that is the kind of environment I'm talking about. Like when two people are talking about some informative stuff, then that's the kind of environment where you usually they get recorded. But now the microphones became so popular that you can even record from your like hostel room. So I recommend anyone to just start a podcast and just share your thoughts about it. So just going back to the talk, audio streaming services are now expanding, and these item catalogs are supporting both music and podcasts. And this is for the reason, like since the transition, there's a step change in the technology, how you can record stuff. So that transition calls for this more active searches, and it has to happen in a very single channel format. So that is to say that there's no more heterogeneous search. Like there's nothing like you're doing, oh, I'll allocate a tab for music separately from podcast, or I'll allocate something else for videos, etc. That's not the case. You want the users to have seamless experience. So as you may have used Spotify app, is just one search field that you look at. So this work was the first study to do joint and music and podcast search, intent prediction, as well as ranking. So the first thing that we wanted to understand, does user behavior actually vary between the podcast and music search? And this research question was primarily analyzed using search logs, and we compiled close to 100 million search sessions, and by sampling logs from instant search sessions over the period of 1 week in June 2020. And we restricted this sample to sessions that resulted in at least one click on the results list. And then we randomly split the data by user IDs just to keep our training and test splits cleaner. So we have 80% of this users allocated to training bucket, and the 10% to validation, and 10% to the test sets. This is an example search log data. So if you type in D, the query starts with D, let's say, you start seeing Drake, the music, it's a music query engine type. Let's say you didn't get the click, and then you type in DR, and then you start seeing the Drake as in full. Then you start proceeding to the next characters. As the user types in more characters, let's say he types in DAI, then you start seeing maybe Daily Show as one of the intents as well, or the candidate that appears. So this is what we are really aiming for. There is enough music catalog intent catalog items, and there is also enough podcast catalog items. We wanted to present both of them when the ranking relevance actually appears to be significant for that particular character, for that prefix. So why this is a more challenging problem than a typical search, let's say a Google search or something? Well, in instant search, you have to present the results instantly, as I said. You cannot wait for the user to type in the entire query. You cannot have, don't have the luxury of seeing all the words and then, then I can make a judgment about, did he mean like Drake, or did he mean Daily Show? So it's more about like just get the results right away on a mobile with almost zero latency, near real time. So that makes this podcast consumption actually what makes this podcast consumption very different from the music consumption? Well, we often notice that people stream podcasts more than obviously the music, and also they add them to the collection. So obviously you don't add podcast to a playlist, so that's where it is very different. And what we noticed people do is, obviously when they're commuting, they listen to podcasts, so they would download the podcast quite a bit. So they would be downloading like nearly 600% more than the actually listening to the or downloading the music. So that's a significant thing. So obviously we want that, give that experience to the user instantly so that they can download more instantly. So what does the search effort look like in podcast compared to the music? So when I say search effort, search effort actually is more related to, does the user have to change their mind when they are deleting characters or inserting characters? That's okay. But deletion of characters or substitution of characters is not okay for the search problem. So you want to control that. The average deletion in characters is much, much more in podcasts compared to the music. And average query length is also almost 40% longer. Sorry, not 40%, 0.4% longer. So that makes it, in this problem is a very different problem, but still we have to solve it in the same setting as we are doing for music. So how can we do this? Well, there are certain consumption differences, and also the way the content is also, the metrics wise, they have different metrics. So this allows us to jointly optimize the ranking and classification of query intent. And that's where we wanted to approach this problem. So a good example of this, like what I was getting at, is if I type in MIC, I want to list Michelle Obama podcast at the top. If I type in MICRO, then I would type in the microphones, the artist. If I type in, let's say, MICROSO, then I want to present Microsoft 365 podcast as the top podcast. So the results actually should change ideally for every character you type in. So the challenges that you are dealing with, obviously, is instant search problem, where the result list need to be updated every keystroke. So therefore, we introduce this character level embedding vectors to our model, and our goal is to enable the model to match the input query prefix to the item description. And our collection consists of these different items, like I said, music and podcast, which is a heterogeneous collection. So we want to introduce a query intent type identification objective as well, so that we can optimize in the neural network using this multitask learning paradigm. At this point, I want to just give a brief moment before I jump into the next part of it. I'll go into the describing the architecture, but if you have any questions, feel free to ask me. If not, I can go forward.
You can move forward.
What is it?
So you can go forward.
Okay, thank you. So what we are doing here is also we are trying to represent the items with their textual descriptions. So that is to say that not always the popular items should be appearing at the top. So often the search use case, as you type in more queries and people click more similar items, then you get stuck in this popularity bias. So the model should try to come out of that popularity bias. So for that to happen, we introduce this item embedding vector, which is independent of this title and also modeled as a lookup table for all the items in the collection. So this is our architecture, a neural network architecture based out of transformers. So transformer is this recent family of techniques that basically emerged in the context of machine translation. So transformer is a general purpose attention architecture where you either apply self-attention or cross-attention across the stacked transformer layers. encoders and the decoders, where you try to come up with a holistic contextual representation for the items or for the words or whatever that you're dealing with in this case. So how they are different from the LSTMs or the bidirectional LSTMs? Well, they are basically much more adaptive to the longer context, whereas in bi-LSTMs or RNNs in general, there would be issues when you have longer context and you always go either from left to right or right to left. Or in the case of bi-LSTMs, you do both bidirectional ways. And in this case, there is no such thing as a direction because the input is presented to the entire in its entirety. So the way we are proposing this architecture is a slight modification to the existing transformer architecture proposed in the Vaswani paper. What we do is take the stacked encoders and we run them and we give the input from based on the characters we see in the queries. The character embedding is learned. At the same time, you're also learning the segment embedding. Segment embedding in this case, you could imagine it's just a token, it's the word. And so once that happens, we also run them through, like I said, it's a multitask learning problem. So we are optimizing for two different tasks. The first one is obviously query intent type identification. It's a binary classification problem. And the ranking one is primarily a learning to rank like setting where you have a list of items that you have retrieved for a given query, and then you want to rank them in order of relevance. So when we are ranking, remember that we can also see just one character, and that is something we have to deal with. Like sometimes you cannot have just a decent embedding for a single character. If I just type in A, or you don't really know what I really mean there. So in that case, what is the natural step to do is like come up with an item embedding which captures the popularity of that particular set of items conditioned on the query prefix. In this case, if you just see the letter A, what is the most popular item that you would be seeing from that perspective? Then that's what that gets an item vector, and then item vector gets passed on to the ranking step. So like I said, we have two objectives. The first one is point-wise ranking loss function, and the second one is obviously the query intent type. It's an auxiliary objective. Even though I say it's an auxiliary objective, they're pretty much balanced in this sense. Like either of them can be a primary objective. And we control how much optimization needs to be done in either of the direction, either the ranking or the intent type. We use a hyperparameter, in this case alpha, which basically controls the impact of it. And both objectives are implemented using binary cross entropy. So in the experimental setup, hyperparameter values are selected based on this validation set that we have, which is of course using the NDCG at 10 as our primary metric. And we also have other suite of metrics like R precision, mean average precision, mean reciprocal rank. All of these metrics are also evaluated in our final experimentation. So of course, we applied pair t-test with Bonforti correction in this case. However, I want to say that at the scale that we are dealing with, like over 100 million sessions in our example set in its entirety, all the results that we see are actually significant in this case. So the results that you're seeing here are where the neural instant search, the proposed approach, the transformer-based architecture outperforms all the baselines in terms of all the metrics. The prefix match and the item popularity is also another metric, another baseline method that we applied. Prefix match is essentially, like I'm saying, like I was saying earlier, if you just see the character A, what is the most popular item that you would see? So it's basically that, and that is trained on several search logs from the production setting. So in a production baseline, it has been running for years together. So Spotify search has been running for probably close to 10 years. So now that production baseline is pretty good at identifying for a given prefix query, what is a good match, right, in terms of item. So in this case, the item would be music item or the podcast item. So a BERT pre-trained model is also one of the baselines that we have used. BERT is again, it's a successor to the transformer work, but in this case, BERT is also just an encoder. It doesn't have the stacked decoders. It has stacked set of encoders. So we use that, and we use that as a re-ranker approach. So we fine tune the BERT base in this case on our search logs. So where the item and the query are fine-tuned. Also, we have had LSTM character-based model. Like I was saying, you could pretty much learn a character level representation for every item. So we do that here as well. So of all the techniques, like of all the baselines, we have seen that our methods perform across the board. Even for the metrics that I'm talking about earlier. And we did some ablation study in order to validate, is the multitask learning indeed relevant or necessary or not? Well, what we noticed is obviously it is necessary for various reasons. Obviously, the item embedding cannot capture, like always, if you're showing the popular items, then the user would not be satisfied because there are long tail of items, and that's why they're coming in for the search, not going into the like for a recommendation or something. So in that sense, the multitask learning as opposed to the single task learning is always outperforming across the metrics. And we also try to observe, is there any consistent improvements between music and podcast? And what we notice is that podcast queries significantly show improvements using neural instant search. And that is for a reason, because there is less item popularity factor here. So the item embedding would be more consistent for music podcast queries, music queries and and the music catalog items. Whereas for the podcast, there are less search logs, and it is still, like I said, it is an emerging media, but it is growing at a scale that is much faster than the music catalog. So which is why it is even more important for us to serve the user better using a multitask learning setting. So we also did some analysis on whether the query length actually matters for the performance. It definitely matters. And if you include the item embedding, especially when the query is so short, like just one character I was just saying earlier, you would see significant gains in NDCG10. Of course, it becomes a flat line after like maybe eighth character or ninth character. You start seeing the gains very few, and in fact, the trend flips when you actually remove the item embedding. You start seeing that the multitask learning actually performs better as you see more characters. Like as you see like 20th character, let's say, in the query, then obviously the trend is obviously the opposite. So which is a very a positive reinforcement in this case that popularity is not always a good thing to have, especially when you have longer context. So that's where I think multitask learning shines. This is another way to show the same the set of results. Like we see the same. It's basically targeting at the music queries versus the the music query versus the podcast queries. We do follow that. We do see that the music queries benefit pretty much when there is very few characters, whereas as you see more characters, then obviously the performance goes better for either of them. So far I was talking about ranking in the search setting, and we have also recently rolled out a retriever at scale in the production setting. And this is basically following the Facebook dense passage retriever approach, where they were pretty much learning vector-based representations for queries as well as the documents in the same encoder space, using the same encoder or joint encoder, shared encoder space. And this is pretty much like a step change from how we were dealing with retriever in the past, using BM25 or TF-IDF based methods, where the term matching, or the lexical matches are actually quite important. But I don't think it should be the case, especially when we are going in multilingual setting, especially for Indian languages. It can be super difficult to come up with a strong lexical matching retriever, because you may not see surrounding context completely because the glyphs and etc. So in that kind of setting, we wanted to have use a universal sentence encoder, so which actually works in 100 plus languages. And we started that from there, and we started to fine tune this universal sentence encoder using our own search log data, as well as we also generated synthetic queries. So like I was saying, podcasts are very difficult to match because they have very long context. You have like podcast descriptions that can go about like 500 words, 1,000 words, etc. So you cannot really expect the users, the previous users who are not familiar with the podcast, to type in queries that are likely to match them. So which is why what we did is I started to think about podcast metadata, the episode, title, description, all that as one long document, and start generating queries from it. And the way we did it is using BART. BART is this, again, a method that was released like in 2020. It was, it's bidirectional autoregressive encoder and decoder method. So that was generating text from a very, considering that the original text was noisy text, you wanted to denoise it. So that denoising process will create more, meaningful context or meaningful text. And that's where what we thought, okay, what if this description can be condensed into multiple queries, multiple small synthetic queries? And those queries look pretty much like what humans would type in if they know what podcast is about. So that was really like specifically relevant for this particular context. And I believe it should be relevant for any limited domain setting where, let's say, you don't have any podcast, any queries issued in, let's say, Telugu or Hindi, then you would generate these synthetic queries in that language based on the original document. And that will definitely help learn a better vector representation, both for the document and the query. So now we index these these document representations, vector representations in Vespa. So Vespa is a search index engine. And then the trick here is that to consider the negatives. As you know, doing a negative sampling in neural networks is pretty definitely hard task to do, because there are various competing ways to do it. Like contrastive learning is one way to do it. Like people also use triplets as a way to come up with negatives. What we tried here is that something more cheaper, which is called in-batch negatives, cheaper in the terms of computational cost. So you have a query and then you have other episodes, podcast episodes. You do the leave one out kind of methodology in order to come up with random negative episodes. So if your batch is like, let's say 128 samples, the query and episode space, then you start generating 127 negative pairs for every pair that you see in the batch. So that's how it works. And we saw that synthetic queries were really improving the retrieval accuracy. And we also saw it was improving the other metrics like mean reciprocal rank as well. And this was across the board. Like we have 3 different data sets So you probably, if you've worked in search, you would know what reformulated queries are. So people, when they issue a query and that the query doesn't work for them, let's say, they retype something else. So they paraphrase or rephrase their query, original query. That's called reformulation. And that reformulation is a very like a free golden data set for you, like if you're working in search. So and if it has to happen in the same session, so you have to know the session boundaries, of course. But if you know the session boundaries, we can save that reformulated query as our gold data set and then use that. And as well as we also, like I said, generating synthetic queries. So we leave out some of the evaluation or held out set for the synthetic queries. And non-reformulated queries are queries that where we had successful clicks in the search logs. So taking the 80% of the search log data set and 20% of the synthetic query data set was the best performing model that we rolled out in August. So when I say rolled out, it's actually in the production right now. So the summary was that we did this search log analysis, which highlighted the differences between user behavior in music search and podcast search. And I proposed this Newland instant search model, which was benefiting both music and podcast retrieval. I also discussed some multitask learning objectives and how they help distinguish between these query intent types. Yeah, and also the baselines that I was describing were quite competitive and how we achieved superior performance than the baseline. Let me know what time looks like for us. Do you think we need more time? We have more time, or I might need like probably 5 minutes more. Or
It's okay, sir. You can take 5 minutes. No problem.
okay. So this is more of a teaser into the long tail content and how we are doing query understanding on that long tail. This is our previous work from CIKM 2020. So what we were doing is long tail content is necessary for this to keep the platform healthy. So you want the users to discover new content, but also the content side, you have some revenue related metrics that you wanted to optimize for. So certain kind of catalog items require more love because they are supported by, let's say, labels. So and they don't get often exposed to the user. So we wanted to identify these non-focus queries. So when somebody types in relaxing music, you wanted to capture the intent there and also match to the underserved content. So content that has very little share in terms of consumption. So that we considered this casual music and niche genre content as our main, like target items. And we wanted to identify non-focus queries that best matches these target items. So for example, the focus queries look like this, like if somebody is typing the Katy Perry fireworks, so the artist name and the song, and there is relaxing music, which is the non-focus queries where you have typed in some relaxing music, and you can match this thing at anything. Let's say you produce some like piano music, and it is underserved, obviously. So we wanted to take your piano music and show it there, as opposed to, let's say, some Hans Zimmer or someone actually composed it, and they obviously get enough popular consumption. So we want you to be promoted. So that's the main logic here. So like I said, niche genre is less familiar, core audience, and dedicated groups of core listeners. And casual music is like soothing, cohesive compositions. So we tried to study we try to study query features that will learn the suitability of a query to include long tail content. We train weakly supervised methods because this doesn't have, again, a lot of label data. So we tried to come up with weak supervision models. And the data was annotated by domain experts. And we ran several online tests. So online tests are precursor to actually rolling out into the production. So where we train two alternative search rankers by using the features that indicate whether the candidate results belong to niche genre or not. And we boosted weights for those features relative to those default features in the ranker. And this actually increased the exposure to the long tail content without without causing any dissatisfaction to the user. And these identified queries for which we consider the treatment ranker have surfaced the niche genre content, etc. And we saw that it improved the gain in exposure. So if you were to record music today, the music would be presented to like millions of users, as much as Hans Zimmer's music or A.R. Rahman's music. So that kind of exposure will actually help new content creators or new musicians. So yeah, that was it. So we managed to produce like a framework for query understanding techniques to detect non-focus queries, and while maintaining the user satisfaction, we were able to surface long-tail tests. This get yielded in promising results in both offline and online tests. Thank you. So that was it.
Yes, if anybody is having any queries, I think you can ask him. Sir, I have a query that can you tell me any research areas there so that our students can collaborate with you and do some work? Because that type of thing is very much essential. So like some research areas where the students' internship can be taken or PhD can be done.
So like earlier I was talking about Trek. Trek is this text retrieval conference where the tracks are pretty much well defined. So if you have someone working on information retrieval, then you know, even in that you have multiple disciplines. For example, the multimedia retrieval versus somebody working on, let's say, neural network architecture, etc., etc. So I think those kind of conferences or tracks are very useful for coming up with your own model and see how it fares against existing state of the art. And I think that makes it easier for you to also obtain data because it's data collected. Let's say, for example, we collected a large amount of data, and Microsoft also runs one of the tracks in that conference. So every major company does this, and that data is released for academic community. That makes it easier for academic universities to work on it without having to worry about large-scale data collection efforts. Just long story short, I think we have seen a lot of universities coming even from China working on this data sets. I think it'll be a great opportunity for majority of the Indian universities also take up similar tasks or in these conferences. Trek is only one of them, but I know like TAC KBP is another conference which is good for knowledge base population, which would be very interesting topic for Indian languages, especially because how do we build a multilingual open domain knowledge graph or knowledge population? Because we have like Wikipedia in, let's say, 20 or 30 different languages with different data, part proportions. So for example, let's say in Assamese, you may have very little data compared to Hindi or Gujarati or I don't know. So I think that's the kind of differences we are talking about, and multilingual, multi-domain question answering, knowledge graphs are really like I think probably the next steps, especially for in Indian NLP or Indian IR communities.
Okay, so any queries?
I have a question. It was a very nice presentation, Dr. Ashish. I can see many of the bachelor students there in the list of attendees. So can you share your experience? What motivated you to do MS and PhD?
I mean, the motivation was, I would say, I used to work at the UDL lab when I was in IIIT, University Digital Library Lab. It started there, I would say, because I was working on NLP problems back then. I even worked on this paper with Professor Ratna Sanyal on Samas Vigraha for Sanskrit. So it was presented at IJC NLP, and that kind of snowballed for me on what path I wanted to take. So I feel like it was a matter of just like being interested in languages. Even now, I'm like crazily interested in like etymology of languages, the words in various languages, and of course coming like like coming from IIIT, obviously you get to meet different people from different states. Obviously, that makes it a huge impact if you're interested in languages, and you can just talking to people like basically.
Sir,
And
can you name some faculties whom you can remember now? That is, when you're studying here, because